Welcome back to the Build Your Own AI video series. In the last video, I discussed how we might integrate the machine learning chatbot into our AI code. In this video, we're going to finalize that. Now, previously, we set up a call to the brain from our client with an action of getResponse and sent the text received from our speech-to-text engine. After testing, I realized it made more sense to embed this call into the voice sensor file, and this is the code here. Now let's take a look at how I'm receiving this request on the brain side of things and processing it against our machine learning model. After some testing, I found that it took 2 to 3 seconds to load the model and all of the Python libraries. That was quite slow and would create a lag in the conversation, so I decided to load the model once in the main Python file here and send it to the process used to handle voice requests. You can see at the top of the file we load the necessary Python libraries, and this is the code required to load the model and the JSON-based list of responses. We then modified our message queue handler to pass in the model, JSON, and other components needed to produce a response from the machine learning model. So let's take a look at the code in our brain_voice file where we can see how the response is prepared. When the action is getResponse, we run our statement through the model to get predictions, and then we get a random response from the highest probability category, unless of course the probability is low. For low probability results, it's likely it's a topic that our machine learning model is not trained on, so we respond accordingly. And we also write that statement to a log file. We can then add a new category and suitable responses to our JSON file later on for those logged statements and rebuild our model for the AI. So let's take a look at the machine learning chatbot in action. Here you can see the brain and the client running side by side on my Linux PC, and you can see the debug messages here where it's loaded the machine learning model in the brain once it's started up. So let's trigger the chat.
Computer, good morning.
Good day, Park.
Computer, how are you today?
Hello, how are you?
I'm good. Computer, who are you?
I am an artificial intelligence. I am called computer. Sorry, I don't have a suitable response to that.
So we can see a few problems there we need to fix up. Firstly, it's not converting the word day part into morning or afternoon, which should be happening on the client side. And secondly, you can see that it actually triggered itself when the word computer was heard. So obviously we're not stopping the hot word detection while we're actually talking. So that's something we need to fix up. But it did trigger the poor prediction code, and you can see here we're displaying the prediction each time that it maps to a particular response. Before we get on to those fixes, there's a couple of things I wanted to point out that have also been updated. We've now moved all of the settings into a settings.ini, and you can see here in the brain.py how we're referencing that with the library at the top. And then further down in the file here you can see we're loading in all of the settings from this using the config parser library now. So that is much more tidy and lets us keep all of our settings in the one place. Now in the test we just did, you may have noticed how the conversation wasn't very natural. This is because we have to trigger the hot word for each interaction. My original plan was to leverage my own chat paths solution and let the machine learning chatbot determine context and direct us to the right starting point. So in the JSON I've set a chat path starting point for the hello category, and I've stored this in the context set node. I'm not sure what Tim from Tech with Tim originally planned for this, but it's perfect for our purposes. I've now modified the brain_voice to check if a value is found in this node, and if so, we build the response from the chat paths database rather than selecting a response from the JSON. Let's now see how that works.
Computer, hello.
Hello there. How are you today?
I'm good, thanks.
Would you like to hear a joke?
Yes, why not?
What is the hottest letter in the alphabet?
I don't know.
B, because it makes boil. Ha ha ha. That one always cracks me up.
That seems much more natural. We could actually move all of the responses to the chat paths database, which would reduce the size of the JSON document we need to hold in memory. So that is something I might progressively do. Now that I'm using the chat paths for the greeting, it should resolve the problem with the keyword day part not being converted to morning, afternoon or evening, as I know it's working with that approach. And I can easily resolve the issue of the chat function triggering the hot word when it says computer by setting the listen flag in the environment dictionary to false when we start talking, as that is the indicator of whether to stop or start the hot word detection. At this point I might end the video, and it's likely it might be a while until I post another. I've shown that the architecture I planned out in the first video works very well, and while we only have one client device or tentacle working with our brain and only two sensors, I see nothing stopping us from expanding both. So where to next? I would like to put a client device at my front gate to occasionally surprise passers-by and to greet any visitors. This will require much more speech-to-text operations and likely blow my free Google allotment, so I plan to integrate the Pico voice engine. The database of chat paths that I integrated needs to be updated and extended to make much more conversation options. And I would like to enable the machine learning chatbot to be able to trigger some functions. A simple one would be, say, asking for security to be turned on or off. It occurred to me that our motion sensor could capture an image every 10 seconds or so and send that to the brain, where I could then have a website that showed the camera feeds from all client devices. And I've always wanted to integrate facial identification so our AI can greet the people it knows by name. Finally, I want to add a timer sensor to enable scheduled actions, such as reminders from our AI, turning secure mode on at night, or conversations that are more relevant to the time of day. Note that my GitHub repository will always have the latest code, and please let me know if you take my code and make any additions or modifications. I'd love to hear about them. So at this point I'll say thank you for watching, and don't forget to subscribe to my channel so you are alerted when I add the next function or capability to our AI.